Ether's fiber, which is not much thicker than a hair, is an optical fiber. It turns the earth into a village. Every message you send to friends and family far away is received on their phones in less than a second. What happens in this process? Before the invention of optical fiber, traditional communication methods like telegraph and telephone could no longer meet the demand for the explosive growth of information. In 1966, Chinese-American scientist Charles Kao proposed the theory of using quartz glass fibers as a medium for light reflection to transmit information over long distances and conducted theoretical verification in the laboratory. The result was very successful, and he was therefore honored as the father of optical fiber. The success of this theoretical verification is based on a principle even elementary school students have learned: total internal reflection of light. This is a glass of water. When you shine a laser pointer at a certain angle, the light passes through the glass and projects a green dot on the wall. Change the angle, and this small dot will disappear because the light undergoes total internal reflection at the water-air interface. If this transparent glass is made thinner and longer, it can be used to transmit light. Moreover, the material used to make optical fibers is similar to glass, but with a higher and purer content of silicon dioxide. An optical fiber mainly consists of three parts: the core, the cladding, and the coating. The core is the heart of the optical fiber, with a diameter generally ranging from a few micrometers to several tens of micrometers, and it bears the responsibility of transmitting light signals. The cladding tightly wraps around the core, with a refractive index slightly lower than that of the core, ensuring the stable transmission of light signals. This causes total internal reflection at the boundary between the core and the cladding, preventing light signal leakage. The coating layer acts like armor for the optical fiber, located on the outermost layer, to resist external damage, moisture, and corrosion. It also reduces friction loss between fibers, extending their lifespan. In practical use, multiple optical fibers are twisted together, just like electrical wires. Of course, there are also cases where only a single optical fiber is used, such as the frequently appearing fiber optic drones on the Russia-Ukraine battlefield. The speed and capacity of information transmission through optical fibers are unmatched by wireless communication. A single optical fiber can control the flight of a drone. How is information loaded onto the light? Inside, the most fundamental code of all modern electronic products consists of only two numbers, 0 and 1, corresponding to high and low levels, which is commonly known as binary. When you type on your phone, "Have you eaten?" the phone will convert this sentence into binary code, which is a series of zeros and ones. In digital circuits, high and low levels represent 0 and 1, while in optical circuits, the intensity of light represents 0 and 1. Humans have been using this principle for a long time. During World War II, if there was no radio communication equipment, gunboats on the river would use flag signals during the day and a light at night. When Zheng He sailed to the western seas hundreds of years ago, he also used light from lamps at night to coordinate the entire fleet. The digital signal then enters the optical terminal, which uses the electro-optical effect to modulate the light emitted by semiconductor lasers or light-emitting diodes according to the zeros and ones of the signal. Common modulation methods include on-off keying, where the light is on when there is a signal and dim when there is no signal. Additionally, based on wavelength, there are many types of light. For example, a set of 0 and 1 codes can be transmitted using the brightness of green light, and another set can be transmitted using a slightly greener light. Different frequencies of light form a frequency band. In this way, digital signals are loaded onto light. The modulated light signal is then ready to go. The speed of light is currently the fastest speed known in the universe by humans. These information-carrying lights travel at a speed of about 300,000 kilometers per second in the optical fiber. The transmission loss in the optical fiber is extremely low, so it can transmit information very far. This advantage reduces the frequency of using signal amplifiers, lowering communication costs. When the light signal reaches the receiving end, the photodetector starts to work, converting the light signal back into an electrical signal. Then follows a series of complex demodulation. The decoding and processing restore the original digital information. Finally, on your parent's phone screen, it clearly displays, "Have you eaten?" Of course, since your phone is not connected to fiber optics, outdoors, the fiber is connected to various base stations. The base stations convert the optical information into electromagnetic waves, then use high-frequency radio to transmit it to your parent's phone. The optical modem installed in your hometown also has this function, and its technical name is a modem, which is its main function. How significant is the invention of fiber optics to us? It makes the internet no longer exclusive to the wealthy, and is the most reliable messenger. Wireless signals are easily affected by electromagnetic interference and radio interference, leading to poor signal stability and difficulty in ensuring confidentiality. Optical fiber, on the other hand, is different. It is not affected by external electromagnetic interference, making the signal stable, reliable, and highly secure. Its bandwidth is extremely broad. In theory, optical fiber can simultaneously transmit thousands of different frequency light signals, meeting the high bandwidth demands of applications like high-definition video conferencing and big data analysis. Optical fiber is a great invention. Without it, you would have to send messages in classical Chinese, as telegrams charge by the word.